Hello and welcome to our presentation Evonik Support Your Wood Coating Formulations. I'm Heike Semmler, working in the Applied Technology EMEA at our business line Coating Additives at Evonik Resource Efficiency. For more than 20 years, I've been responsible for the market segment wood and furniture coatings. During the next 30 to 40 minutes, we will have a closer look into the world of wood coatings. We will provide some market information, including market figures and some market trends of the future. In the second part, we will look a little bit closer to the technology of wood coatings, including the different binder technologies and, of course, the composition of a furniture and a parquet lacquer coating. Last but not least, we will discuss challenges in wood coatings and how especially the Evonik products can tackle these challenges. But before we start with the technical presentation, let's have a look on the substrate itself. Wood. Since immemorial time, human beings have a very close relation to wood. Wood is used, for example, as an energy source, as construction material, or to manufacture items of the daily use, such as furniture. But wood undergoes a natural degradation if it's exposed to weather conditions, like rain, humidity, or sunlight. So it's quite obvious that the wood needs a certain kind of protection, and coatings is one possibility to protect the wood from the natural degradation. And here starts, I would say, the fascinating thing of wood coatings, because there are a variety of possibilities to coat the substrate wood. For example, to get a just pure natural looking appearance, to make it more colorful, or to play around with different gloss levels, to make it glossy or deep matte. And last but not least, special coatings are also possible from a purely natural looking with, for example, waxes, for a certain antique look, up to clearly, I would say, design colors. 76% of the wood coatings is applied on furniture. So that means furniture for bedrooms, living rooms, kitchen or kitchen cabinets. The dominating technology is solvent-borne, so that would mean two-pack PU systems, nitrocellulose, acid-catalyzed systems, for example. This market is dominated by a huge competition, and most of the coatings is produced in Asia, with more and more restrictions on solvent-borne technology. The major requirements are, of course, the appearance of the wood coatings, but also mechanical and chemical resistance. The second subsegment, the joinery coating, with 90% of the wood coating market, means coatings which are applied on doors, windows, stairs, skirting boards, panels, or garden furniture. Industrial applied coatings here are water-borne technology, which is used by 1K acrylate systems. It's also a very highly competitive market, especially there is a competition to alternative substrates. If you think about windows, for example, which can be made also of PVC, for example. The major requirements here are durability, also resistance, for example. The last group are the parquet lacquer with 5%, also a very small but increasing market. Also here we have technology of UV and water-borne. And the resistance is one of importance, durability, and especially the scratch resistance is of importance. Like in the past, annual growth rates of 8% will also continue in the future with round about 7%. The wood coating market is dominated by the Asian Pacific region, especially China, where we can expect growth rates up to 10% yearly. The second large market is the European market. Here we can see that the 80% of the wood coatings is applied in the European Union. The growth rates here are around about 1%. In North America, where we can see also growth rates around about 3%, there a technology shift will be to water-borne, especially for primers used for building blocks. The South and Middle American market is dominated by Brazil. Here we will have growth rates round about 5%. As mentioned several times, the solvent-borne technology is clearly dominating wood coatings. And if we look over the years, we can see that solvent-borne has still a huge amount of coatings in the market. Of course, the growth rate is still nice, so solvent-borne coatings will grow with 2.5% yearly. But the new technology like water-borne and especially UV, they will gain more and more market share. And especially if we look here on their annual growth rate, which is expected, was 9.5%, for example, for the UV technology and 6.6% for the water-borne technology. So we can say that, for example, for the year 2018, where we have 2.9 million tons of wood coatings, which are produced worldwide, we can roughly say that 70% of these coatings is solvent-borne, but clearly is descending, 20% water-borne, and 10% radiation. And both technology are ascending in the future. Now let's look a little bit deeper in the different binder technologies which are used for wood and furniture coatings. Of course, they differ in their market share and also in their innovation potential we can expect for the future. 2KPU solvent-borne system, they are dominating the wood and furniture coating market. They have a quite high market share, but it is a so-called mature technology, so we would not expect more innovations in the future. That's the same with the nitrocellulose or even the acid catalyzed systems. They are, I would say, quite old technologies, and here there will be no real innovation in the future. The more innovative technologies and binder systems are clearly the water-borne and the UV technology. And if you add or calculate the 1K water-borne together with the UV water-borne and the 2K PU water-borne, this technology already has a quite nice market share. And we expect here in the future, especially for the 1K systems, more innovation in respect to mechanical and chemical resistance, so that there is probably a chance in the future that the 1K water-borne system can replace classical solvent-borne systems. For the UV technology, especially the solvent-free UV technology, we can also expect high innovation potential, and especially that will be or can be seen in the fact that the UV technology is gaining more and more market applications. So it's more and more widely used. And here, of course, the innovation in UV solvent-free system can help to gain more application fields with UV solvent-free formulations. If we look to the future of wood coatings, we clearly can say that there is a technology shift from solvent-borne to water-borne and UV wood coatings. So there is an ongoing process to replace solvent-borne wood coatings by these two environmental friendly binder technologies. Of course, there are regional differences about this replacing process, and also the speed is different depending on the region we are looking on. 100% solid UV formulation will also increase in the future, mainly due to the reason because it's gaining more and more application fields. Like, for example, it can be nowadays used for curtain coater application, roller coating, and there we get very nice high gloss with excellent flow coatings. Another argument is that the investment or the maintenance costs for UV technology has decreased in the past, and especially the LED technology will also help to make this 100% solid UV technology more and more important. Water-borne UV and 2kPu water-borne system are gaining more of interest, mainly because of their high durability and resistance. So idea is that they are partially able to replace classical solvent-borne 2kPu systems. And the water-borne 1K acrylic technology will also have increased interest because in the case to match classical solvent-borne coatings like acid-catalyzed or nitrocellulose. Now let's have a look on the typical composition of a furniture coating. We start with the wood itself, and sometimes it can be stained to give it a certain coloring effect. Then a primer, and finally a top coat is applied. From the technology which is used for the primer and top coat, we are quite flexible. We can use all binder technologies, like for example 1K acrylic water-borne systems, 2kPu, nitrocellulose, acid-catalyzed or UV technology. And all these technologies can also be used interchangeable, so a lot of different combinations are possible. But at the end, what is important is a fast drying process and very short production time. The functionality of the primer is mainly to give the good wetting to the substrate, to the wood substrate, to give it a nice brilliant appearance, a good body, or to wet out the pores. We need sandability and of course recoatability. For the top coat, mainly optical aspects are of importance. With the top coats, we influence the color, the gloss levels, for example, but also things like mechanical or chemical resistance. Which coating is used for the primer and for the top coat is also depending on the shape of the substrate, on the applications technology which can be used. So if it's spray applied or roller coated or curtain coater applied. And of course, it's depending on the different requirements of the end user and regulations we have to fulfill. Now here we see the typical composition of an industrial applied parquet floor coating. On the first view, it looks much more complicated than the furniture coating we have seen before, but this is not correct. We start again with the wood, which can be colored by a stain, for example. Then the adhesion primer is applied, and adhesion primer is important to have a good adhesion between the substrate wood and the following coating layers. It can be based on UV technology, but also on water-borne. Here are pure acrylics which are used. A barrier coating can be applied, especially when we have a very oily wood which is used. Then we need a barrier coating. A putty is applied. That means something to get rid of damages or holes and to prepare the coating for the next one, for the sealer. The sealer is applied in several layers and based on UV technology. The sealer gives a good abrasion resistance, and that could be done, for example, by adding aluminium oxide to these formulations. Finally, a top coat is applied again in several layers, and the top coat also gives a certain optical appearance, the gloss behavior, the leveling performance, but also some scratch resistance, which can be achieved by silica materials, which also Evonik provide to the market. Why is the sealer and the top coat applied in several layers? The reason for that is that by applying several layers, we get excellent intercoat adhesion. And that gives very good impact resistance to the parquet lacquer. Now we come to the last part of the presentation, the various challenges we have in modern wood coating formulations. And this animation symbolizes some of the challenges we are facing in wood coatings. For today's presentation, we will just focus on some of these challenges. For example, the challenge of adhesion. We will talk also about defoaming and dearation aspects, anti-blocking, chemical resistance, matting effect, and scratch resistance. Now let's start with the first challenge, adhesion. Adhesion is the good link from the coating to the substrate wood, or a very good link between different coating layers. It's often tested by a cross-cut test, as you can see in the two pictures. Of course, we want to have good adhesion, which is indicated by the left picture. And the problem of adhesion can appear, and that's what you see in the second picture on the right. For example, when there is a very poor sanding of the first layer, and so the second coating cannot really penetrate the first layer, or if there is a change in polarity of the first layer, which can take place when the coating is aged, for example. To achieve good adhesion, it is also important to have very good substrate wetting. Substrate wetting is the spreading of the coating on the substrate and penetrating into the substrate. Poor wetting can, for example, occur if there are impurities in the liquid or on the substrate. Poor wetting can also occur if a coating needs to be applied on an aged coating. So that means if we want to, for example, repair a parquet lacquer, so then there will be a fresh material on an aged coating. So here, poor wetting can occur. To have a very good adhesion, it is also important to select the right binder technology. For example, water-borne wood coatings are often based on acrylic emulsions. Evonik offers, with the Viscosity types, acrylates that can be used to create acrylic emulsions. Especially with the Viscosity MEEU building block, it is possible to create acrylic emulsions with excellent adhesion performance. The reason for this excellent adhesion is the urethane group which is in the acrylic building block. With this urethane group, we get additional adhesion to very polar surfaces, and even at humid climate, we can achieve a very good wet adhesion. For good adhesion, we have seen that it's possible to modify acrylic binders by, for example, building blocks like the Viscosity MEEU. Beside that, we can improve adhesion by excellent substrate wetting. And this is what you see in the next slide here. Here the test is done or is based on a water-borne furniture coating, which is applied on a solvent-borne sealer fixed on a plywood substrate. The application is made by drawdown, and after drying, we made a cross-cut test. The left picture, you see that we have quite poor adhesion. On the right picture, we could be able to improve the adhesion by just simply adding an additive called sulfonyl 104. The sulfonyl 104 here gives us very good substrate wetting, and that's, as I said, a precondition for very good adhesion. Defoaming and dearation is another very important challenge we are facing in wood and furniture coatings. This challenge is especially relevant in water-borne formulations. The reason is that when water-borne formulations are produced and applied, a lot of foam is generated. We distinguish two different kinds of foam. The microfoam, that's foam bubbles in the coating film, and macrofoam. This is the formation of foam bubbles on the coating surface. Why is, for example, microfoam a problem? If we look on the left side, here the picture, we see the problem of microfoam. This is the picture we would see via a microscope when we look on a coating that has a lot of microfoam inside. The problem here is that with each micro bubble, the protective film thickness is reduced. So of course, we want to eliminate the microbubbles, as we can see in this picture here, and that can be done by so-called deaerators. We can eliminate the microbubbles, and at the same time, we get a very clear and transparent coating. In case of macrofoam, and that's on the right side here, we have bubbles on the coating surface. That's not, it's also, let me say, a question of quality or a problem of quality, but also, I would say, a question of appearance. So definitely here we want to eliminate macro bubbles as well, as we can see in that picture here. And that can be done by so-called defoamers. On this slide now, you see an excellent example for good deaeration effect and the elimination of microbubbles. We applied a water-borne 1 kPu formulation by air mix application. To eliminate microfoam and macrofoam, we add defoamers and deaerators just under normal shear forces to the formulation. Via the application, so the air mix application, 250 microns were applied. After drying, we evaluated the film with the help of a microscope. And these are the two pictures you can see here. The picture on the left, if you look there, you see there are still some microbubbles in the film. So the products we tested here are not very effective against microfoam. The picture on the right side, there is nearly no microfoam bubble. And the reason for that is that we used an excellent deaerator, very effective deaerator called Tegoarix 902W. Defoaming waterborne wood coatings means to find the right balance between efficiency and compatibility. On this slide here, you see the test result we obtained by applying a waterborne parquet lacquer based on a PU acrylic emulsion on an oak parquet. The application is done by roller with 2 to 3 layers without sanding in between. In addition to that, we made a compatibility test. That means we make drawdown of the coating on Leneta card and evaluate craters, fish eyes, or turbidity. For evaluation, we judge the foam behavior and the compatibility, and 5 in this case means we have excellent surface, no foam, and 0 means mass of craters and a lot of foam. Now I have a closer look to this diagram, and there you see we tested compatibility and defoaming action, and especially the defoamer Tegoarix A22 performed very well in both cases, efficiency against foam and compatibility. So that's an excellent choice for waterborne parquet lacquer applications. Now if we look a little bit more into the mechanical resistance of wood coatings, 2 challenges are quite important here. That's anti-blocking and anti-scratch. Anti-blocking, this is what you can see on the left side of the picture. Anti-blocking happens when you put coated parts or 2 coated parts together, coating by coating, and they stick together and they're glued together. Finally, you cannot remove the parts. Or you can remove them, but then you totally destroy the coating film, which of course is not desired. The other challenge is the scratch resistant. And the word indicates more or less what it is. So of course we want to avoid damages by scratches so that we have still very nice surface with excellent scratch resistance. To overcome these challenges, anti-blocking and anti-scratch, 2 approaches are possible. One is the incorporation of specific additives to the coating formulation. The second approach is to design specifically polymerics with certain properties like anti-scratching or even anti-blocking effect. Anti-blocking performance can be improved by surface modification using specific surface control additives. The test we have done here is based on a joinery coating, based on an acrylic emulsion type. The joinery coating is applied on 2 panels with 250 microns wet. After 5 hours drying, 2 parts of the application are put together and then pressed together. For example, putting a weight on top, for example, 1.6 kilogram per square centimeter. That's the normal test condition we selected. After 24 hours, we try to remove the panels from each other. And in case of the control, we achieve this result. So the surface is destroyed, so there's a very poor blocking resistance. Now, in case of using the Tegoglide 490, we received an excellent result in anti-blocking, so there is no surface defect and excellent anti-blocking performance by the surface control additive Glide 490. The mechanical resistance of wood coating can not only be influenced by the right selection of additives, but also by the right selection of binders. Water-borne wood coatings are often based on acrylic emulsions. And Evonik offers specific acrylates to modify acrylic emulsions. These building blocks, so-called Viscosity, differ in the TG, and by that they provide different properties to the acrylic emulsion. For example, the Viscosity MMA with very high TG gives hardness to the acrylic emulsions, up to the Viscosity IDMA, which is more softer and gives obviously softness to the acrylic emulsion if it is used for emulsion polymerization. The state-of-the-art technology for water-borne wood coatings today are the so-called core shell structure. Here we combine different properties together in one polymer structure. For example, we can use a hard core with, for example, MMA, cross-linked with AGDMA, and add in addition a soft shell on the core, giving, for example, other properties like low resin viscosity, good coalition, resistance against polar media. So with this core shell technology, we are able to mix or to provide acrylates with different properties. So for example, very nice scratch resistance in combination with good resistance against polar media. Finally, we can say that with the Viscosity building blocks, we can adjust in a wide range the hydrophobicity and also the flexibility of the resin. And that finally gives coatings that have a certain mechanical resistance. If we now think about 2KPU solvent-borne system and think about scratch resistance, of course, these formulations are already very good in scratch resistance because of the cross-linking density. And Evonik offers cross-linkers, so-called the Westernard types. But it's possible to increase, even for these systems, the scratch resistance and also chemical resistance. This is possible by combining the polyurethane cross-linker chemistry with the Silan chemistry. And what we obtained here are so-called Silan polyurethane hybrid cross-linkers. These are also under the brand name of Westernard. Cross-linkers are used to generate highly scratch resistance and chemical resistance, for example, for wood coatings. And you see a nice example here. The picture on the left side, there we see the outstanding scratch resistance and how it's possible to improve the scratch resistance for a standard 2KPU system by the specific cross-linkers. The major advantage of this cross-linker, called Westernard EPMF, is that coatings get outstanding durability. It's still fast curing cycles and can be used in 1K and 2K formulations. It's a plug-in technology for achieving excellent chemical resistance. We have already a product line of products. So the Westernart EPMF 201 is a standard grade. And then we have others which have more flexibility or are combining improved drying speed and flexibility. Now let's have a closer look to the chemical resistance of wood coatings. And also here, different approaches are possible. Of course, in a highly cross-linked coating film, we can say that the chemical resistance is already very good. For example, coatings cross-linked with the Westernart cross-linkers, we can obtain coatings with very high hardness and flexibility at the same time, extreme light stability, and excellent chemical resistance. But this is just one part of the story. It is also important to select proper additives in order to have good chemical resistance of the coating. For example, the selection of wetting and dispersing additive is quite important in this respect. Wetting and dispersing additives are used to stabilize pigments, and they can generate high gloss, excellent color development, pigment stabilization, and low viscosity. But also they have a huge impact on the chemical resistance. So it's important to select these additives in a proper way. And here, for example, the Tego Disperse and the Substrate wetting and dispersing additives are a good choice to obtain good chemical resistance. To improve resistancy of solvent-borne 2K-PU system, Evonik offers specific polyisocyanide cross-linkers called Westernart. Westernart T, for example, is a cross-linker to improve physical drying properties and boost chemical resistance of weather-resistant and light-stable solvent-borne 2K-PU systems. It can support the hardness momentum to soft Westernart HB, Westernart AT types. It is very compatible and booster for obtain extreme durability and chemical resistance. In addition, it can be used as a drying accelerator. Two other types are available, the Westernart HT and Westernart HB. These are cross-linkers used to generate weather resistance and light stability to solvent-borne 2K-PU systems. Their advantage is very good durability against environmental impact. They have high reactivity even at ambient temperature and beneficial balance between performance and price. Now let's see how we can influence the chemical resistance of a wood coating by the proper selection of a wetting and dispersing additive. The testing we did here is based on a water-borne furniture coating, white pigmented. The test setup is done in this way. We apply the water-borne wood coating on a Lenetta card with 200 microns. And then, after drying for 7 days at room temperature, we add different chemical ingredients on the surface, for example, coffee, mustard, or red wine. Then after 2, 4, 6, and 24 hours, we remove these ingredients and check the discolorization of the furniture coating. And the less discolorization we have, the better is the chemical resistance of the coating formulation. Now we tested 2 different kinds of wetting and dispersing additives. One is based on a standard wetting and dispersing additive. This is what you see, or the test result you can see here on the right side. And we compare to another one, wetting and dispersing additives called the Methacrylates 3600. And it's quite obvious, and you can see it quite easy, that with the standard material, with the standard wetting and dispersing additive, we have quite a high discolorization, especially with the coffee and also with the mustard. Using the Methacrylates 3600, we nearly have no impact on the chemical resistance of our waterborne furniture coatings. So that would mean that the Methacrylates 3600 is an ideal wetting and dispersing additive for chemical-resistant waterborne furniture coatings. Now we come to the last challenge for wood coatings, the matting of wood coatings, which I think is a very essential and very important formulation element. By adding matting agent, we can create semi-gloss or even very deep matte coating surfaces. By working with matting agents, it is important not to negatively influence the transparency of the coating. And beside that, to have as well no negative impact on the viscosity of the wood coating. 100% UV formulations, so solvent-free UV formulations, are quite difficult to matte. In order to have really deep matte surfaces, high amount of matting agents are normally necessary. And this high amount of matting agent can have a negative impact on the viscosity of the formulation, which is especially relevant for the roller application, which is a typical application for UV parquet and UV furniture coatings. The pictures here indicate how this viscosity behavior can negatively influence the application. For example, if we have a very strong viscosity increase by, for example, a high amount of matting agents, we will have a negative impact on processability in the roller machine. At the end, that could mean that we have to stop the application process. The best option is, of course, to get a Newtonian flow behavior of the UV formulation, and that will indicate a very good and excellent processability. The machine can run without any problems, and the transfer of the coating to the substrate is very good. Now we have seen that for matted 100% UV formulations, the viscosity is very important. We tested now the impact on matting efficiency and viscosity of different matting agents in a UV furniture coating. The left diagram, there you see the needed amount in gram of different matting agents to obtain a gloss level of 15 units at 60 degrees. Here we see that especially the ASMAT 3300, but also the 3600 just need lower amounts to get this gloss level compared to the two competitor products we tested. In the second diagram, we have now focused on the viscosity impact. And now here we can see that especially the ASMAT 3600 has nearly no or just a little impact on the viscosity. We nearly got a Newtonian flow behavior here. So finally we can say that the ASMAT 3600 is the ideal matting agent for matted 100% UV formulations. This brings us now to the end of the presentation. In case of questions, please feel free to contact my colleagues directly. For example, for the Westernart crosslinker, Dr. Guido Streukens or Tobias Unkelhäuser. For the Visumer products, Dr. Michael May. And for the coating additives, Dr. Nina Hoppe or myself. Thank you for listening and your attention. I hope you enjoyed our journey into the world of wood coatings. Take care and bye-bye.